Okay, so in this example 4, determine an equation from the graph. So this graph can be a sine graph or a cosine graph. We just have to apply just slightly different parameters, because the cos graph can map exactly onto the sine graph if we shift it. We just saw that as we just did this on the calculator. So those are the exact same graphs. All right. Now, write the equation of the function in the form of y equals a sine b x minus c plus d. So we need to find parameters for a, b, c, and d. So if you look at this graph, and again, we're going to make it a sine graph, right? So what you might want to do, and again, there's lots of different possibilities for a sine graph with different parameters, right? Because it's periodic. So you just pick, and this is what I would do. I would pick a starting point for a sine graph. This looks very sine-ish, doesn't it? Right there, yeah, sine-ish. Okay, so what I would do is I would say I'm going to try to adjust my parameters a, b, c, and d so that a regular old sine graph will map right on top. Now if you want, where's 2 pi? Way over here. If you want, you could map or just sketch really quickly a regular old sine graph. And I'm going to do that in, I don't know, just green for now. So watch this. So from 0, it should go up. So pi over 2 is going to be, I guess, about there-ish. Right? And so it's going to go up to pi over 2, down to pi, down to -1 here. So this is what my regular old sine graph looks like. So you can see right away that the sine graph has been squished up horizontally, right? So that's a b. Is that a b greater than or less than 1, do you think? What is that? Sorry? Greater than? So think about b as how many waves can you fit within a regular 2 pi period. So that's how the b is viewed. Or 2 pi over b would be the single period. So the period length is pretty small, so that b is going to be greater than 1. Okay. All right. So you have an idea. Also, looks like it's been shifted to the right a little bit, right? And it's been shifted up a little bit. Okay, what about the amplitude? I mean, right away you look at the amplitude and you say from center to the maximum displacement, how many units is that? It's 2, where normally a sine should be 1. So right away you've got an idea of what your parameters should be. So A, we just said, A for the red graph, maybe I'll do that in red. So A for this one is going to be 1, 2, right? It's just the amplitude. So A is going to be 2, and we can keep it positive because we're starting here, ending here, and it goes up first. If we started at a point, I don't want to confuse you, but let's say we started at, this point right here, and we went down first. Okay, if we were going to set parameters for this one, and again, it could be the same graph, just with slightly different numbers, we would say, hey, A is going to be negative because it's going to go down here, and then we'd have to attach a certain phase shift so that we start here instead of starting here. So I'll let you just absorb that a little bit, but anyways, so we're going to start here and here. Oh, let's get rid of those other dots too. Okay. All right. All right, so B. Can we figure out what B is? What is the period length for B here? So this to this. Okay. So what's that gonna be? What is this right here? This is pi over 6? Would it be? 1 pi over 6, 2 pi over 6, 3 pi over 6, okay? So this is 4 pi over 6 and 5 pi over 6. All right, so again, I'll get rid of the green graph now. But do you see how we have the period length goes from pi over 6 to 5 pi over 6. So what is that period length? Because that's the easiest thing to start with is period length. So 5 pi over 6 minus pi over 6, right? That's the length of one period. And that's going to be, what is that, 4 pi over 6 or 2 pi over 3? Now, an easier way to do that, and this is fine, this is great, but look at, you could go from 0 and find out, hey, where does that come back to its starting point? And here it is, 2 pi over 3. So you could just look at other places for the period length, no problem. Now, the period length, again, though, that tells us period length is 2 pi over 3. And remember, over here, period length is determined by 2 pi over b, right? So if our period length is 2 pi over 3, what is the b value? Yeah, it's 3. This is easy, right? So b is 3. Everyone see that? And it's nice that it rhymes too. B is 3. Okay. Any questions about that? Are you guys getting that figured out?
Period length is like 5 pi over 3.
Sorry, say that again?
What if the period length was 5 pi over 3?
Okay, what if the period length was 5 pi over 3 and not something simple like this? Okay, so then you would, okay, just as an aside, if the period length was 5 pi over 3, then you would still solve for b. Okay? So again, you want to get b kind of all by itself, so that goes up there, this goes over there, that comes down here, right? So you end up, b would be equal to 2 pi times 3 over 5 pi. The pi's cancel out, so this would be what? 6 over 5. That would be your b. Okay, just as an aside. So just set it up like that. Period length equals 2 pi over b. Fill in period length, solve for b. Just like you would put in the b and solve for period length if you had to. Okay, can we move on? Is that good? Question?
B is not gonna, it can't be minus 3.
Oh, can b be minus 3? Okay, well that's a good question. Can b be minus 3? Right now we're taking a look at this period right here, right? Going forward. Now, what does a negative b do? Do you remember? Yeah, it flips it which way? Sideways, right? Okay. So again, because this is a periodic function, okay, if we started over here and said, oh, let's go backwards this way, and then let's make it a negative b and flip it all the way over here, you could do that. But right now, we are starting from here, going here. We don't have to mess around with a negative b. Just keep it positive, okay? All right, but yeah, a negative b would flip this part over to the other side, and it would be over here. So really, looks like it would map onto itself over here. So positive or negative in this case, yeah. Well, again, so b being negative, again, there's an infinite number of possibilities of different parameters you could put into an equation to write the same graph, right? So you could take it and you could flip it. You could also flip it this way. You could, and then you could kind of undo what you did by another parameter. So there's a lot of different possibilities. We're just going to try and keep it as simple as possible here. These are all good questions. But yeah, we'll just keep this positive to focus on this little section, okay? So we've got A and B figured out. Now what we have to do is we have to figure out what is the C value. So here's the, the phase shift. We would go from a 0 over here to what? Where does it actually start? At pi over 6. So how do we express this? So C is actually pi over 6. Because it's moving to the right, the C value is actually positive. And of course, in the equation, that's going to show up as theta, or x here, I guess, x minus pi over 6. But the C value is positive pi over 6. Okay? So that's C. Well, because we would be moving this from the center position of 0 over to the right. So if we move the graph to the right, then that is a positive C value, but in the equation when we get to it, it's going to show up as a negative, minus C. So we'll get to it there, but because it's moving right, C is actually positive. Everyone see that? You see it? Okay. No one got the jokes? See it? All right. You did, but it's not funny. I get it. Okay. D. Now, this one's easy. Where's the midline? Okay. It's originally at 0, but now it's at 2. So D is positive 2. All right? So we're pretty close here now. So let's put this all together and write our equation, and then we'll graph it to see if this looks like it might be the proper graph. Okay. So y equals, A we said was 2. Sine. Now, what is B value? Well, that's 3. And you can use a double set of brackets here. You don't have to, but you can. Sine of 3. And then we have x minus this c value, so this is where this shows up as minus pi over 6. And then, of course, plus d, so that's plus 2. Okay? So, how does that look? Does that look like, look good? So what we could do is we could graph it, either on Desmos or on your graphing calculator, and just kind of check some points. All right? So maybe we'll do that. Okay, so here's the graph graphed out. Now, if we look at some points here, we should have 0, 0. Is that the case? Yeah, we do have 0, 0 there. Other points that we should have 2 pi over 3 and 0. I guess that should be on there. And so there it is, 2 pi over 3 and 0, so on. A maximum of 4 at pi over 3. And so you could just kind of double check this, pi over 3 and 4. It appears to be the exact same graph, so you can kind of double check it that way. All right? So I'll let you guys maybe take a look at the cosine part, okay? So why don't you do the same thing, and I'll give you a chance to try it out, and then do the cosine, do the b part on your own. See if you can do the same graph using cosine. Okay, so you've all had a chance to maybe give this a try on your own. So this is what I did, and again, there could be multiple answers for this, right? Depending on how far you shift it over and everything like that. So there could be slightly different answers. But I saw this as a cos. Now look at this. This is a cos that is kind of flipped upside down, right? And the reason why I saw this first is because this starts at 0. And so there's no shift left and right if you look at this as a cos. Now this is going to be a negative a value because, as you know, the cosine normally goes like this, right? It starts up, comes down, and goes up. But this is a flip. Yep?
In the question it says A has to be positive.
Oh, it does say A has to be positive. Oh, okay. That's why they have a different answer. Thank you for noticing that. I didn't even read that. Okay, so let me just go through this, and then we'll do that with A being positive. Thank you for pointing that out. So I did A negative because that's going to be the easiest. So let's just go over that real quick. So if A is negative, it's a flip. And also the amplitude is going to be 2 as well. You see that from center to maximum displacement is 2. So A is going to be negative 2 in the way I did it. B, okay, so B, again, we're looking for period length, right? Well, the period length here is 2 pi over 3. And we already established this from A. So that's the same period length, so B is going to be 3. Now, with A being negative, I didn't have to shift it. So C is actually 0. Because you don't have to shift it left or right. It does start right on the y-axis there. And then, of course, D, the midline is y equals 2, and so that's this. So the one I initially did was negative 2 for A, 3 here, and then really just a 0 there, and then a plus 2. And so, of course, you don't have to write the plus 0. This is just the same as cos 3x. And I did check that on Desmos, so I typed the one that I got in here on Desmos, and here's the original that we know is correct, and if we light this one up, it's the exact same. So that's one way. Now, the question did say, and this was well noted, that A should be greater than 0. So we can't assume that we're going to flip it. So then what you might do, this is going to be different, the B is going to be the same, this is probably going to be different, but this is probably going to be the same. So what we have to do is we either have to go back to a point right here where you see a sine graph, or we have to go forward to maybe here where we see a sine graph, or cosine graph, or you could go forward even more and start here if you want. Doesn't really matter. But you see, you have to either shift back or forward. Okay. So I don't know what's going to be easiest. I'm going to do the shift back actually. So I'm going to start here. I don't know if anyone else did, but I'm going to start here and say, you know what? There's my sine graph. And the A is going to be positive 2. The B, okay, negative pi over 3 to positive pi over 3, that's still 2 pi over 3. And that means a B is 3. Now the C value, I have to shift what would be a regular cosine graph. I have to shift it back pi over 3 units. So the C is negative pi over 3, which is going to show up in my equation as a plus, right? And so you would still have to move that cosine up 2 units to get to the midline. And so these would be parameters that also should work, so let's give that a try. So if this is positive 2 now, that means I have to shift the graph to the left, so that's going to be a minus a negative pi over 3 plus 2. And of course that's going to simplify to plus pi over 3. All right, did anyone get this equation, this exact one? No, nobody did? So you guys shifted to the right somewhere further? Okay. So let's give this one a try. Again, I'll go over to the Desmos here, and I'll just keep that up. And so what was this? This is going to be, oh, that's a good thing I kept that up. That's going to be a positive. This is going to be a 3, and then the x is going to be, what did we say? Plus, was it pi over 3? No, pi divided by 3. These brackets are always a little bit goofy. Bracket, bracket. Okay, so does that look like what we just had there? 2 cos 3 of x plus pi over 3 plus 2. Okay, so let's just see, moment of truth here. Let's see. Oh, look at that. That one works as well. You see the red and the blue is on top? So that one works. So what did you guys have? Something different? Oh, you had minus pi over 3. Oh, okay. So instead of shifting to the left to start here, you shifted to the right to start here. Perfect. Everything else would be the same. That should be the exact same. So let's just double check that. Whoa, there we go. X, that doesn't work. And then you said, sorry, minus. There you go. So that's like a shift to the right starting there. Perfect. Anybody else? Anything different that we want to check? Okay. We could also shift it, instead of pi over 3, we could go 1 pi over 3, we could go 2, we could go 3 pi over 3. So did anyone try shifting it a whole pi units over? If we just put a pi there, look at that. Still the same. So 3 times x minus pi. Okay? You see that? So there's lots of different ways you could do that, and I hope that makes sense for you there now.